So as I said, this is the inaugural Galaxy Forum in New York City, and I certainly trust it won't be the last. Just like Professor Janoff set the tone for our meeting by situating ourselves here at Grand Central Terminal. And I think one interesting question I had for Professor Janoff when we met was how many people pass through here. And it depends on what standards you use, what metrics, but if you count everybody on the subways that goes by, I think the figure was 175 million per year.
Per year, yeah.
It's a lot of people, a lot of riders. To set the tone for our Galaxy Forum in my talk, we can keep in mind that while everything seems stable on the outside, we are spinning on Earth at 1,600 kilometers per hour at the equator. The sun and all its planets are spinning around all the planets are spinning around the sun at 108,000 kilometers per hour. The sun is one of billions, hundreds of billions of stars orbiting the center of our galaxy every 250 million years. In other words, our galaxy is about 16 galactic years, 4 billion years. And everything is moving along the four-dimensional space-time helix. That framework of galacticity established a little closer to home, although I like to think that as big as the galaxy is, it's not that far out. We're standing on it. We're all part of the galaxy. We're not yet part of the moon. But that's what our business in Hawaii is, to bring Earth to the moon, using the moon to get to the stars, and with our astronomy program, using the stars to get to the moon, a nice closed loop. We started with a single idea of putting an observatory on the moon, and the idea grew into a project, grew into an association, and that first idea still manifests as what we call the first International Lunar Observatory, ILO-1, with a 2-meter antenna to be placed at the south pole of the moon, specifically at a mountain at the south pole of the moon that is called Malapert Mountain, but no doubt will be renamed by the first landings there. Before we were able to make that much progress with ILO-1, given its complexity and cost, we happened across earlier accesses to the moon with the precursor missions. The ILO-X is a 7-centimeter telescope that has been already developed and waits to be placed atop a private spacecraft developed by a company called Moon Express, chaired by Dr. Bob Richards. The instrument is already complete, except for the space testing and hardening of it. Moon Express is one of 20-some-odd enterprises competing for the $30 million Google Lunar X Prize, which was started in 2007. It has a termination date of 2015. High likelihood that will be moved back a year or so. But it's possible that there will be attempts to land a rover on the moon next year by one of these 20 Google Lunar X Prize teams that are located not just in the USA, but around the world in other countries. Even before the precursor became possible, we took advantage of the opportunity of the first spacecraft that has landed on the moon in 40 years. Last December, the China Chang'e 3 spacecraft was launched and successfully landed at the northern equatorial area. We had developed collaboration with the Chinese astronomers in an exchange to have a peek through their telescope, which sits on the Chang'e 3 lander. It's a 15-centimeter, 6-inch ultraviolet telescope, near ultraviolet telescope. And in exchange for our using that instrument to observe for the first time from the moon galaxies, we've offered Chinese astronomers the opportunity to use our telescopes when they arrive on the moon as well. The idea being that the moon is probably the next major frontier of astronomy. We've operated space observatories now for over 40 years, and Earth observatories are getting larger and more powerful all the time. But this is the first time astrometric calculations, astrophysics have been performed from the moon. And if these precursors prove successful in the atmosphere-free conditions of the stable platform on the moon, if they prove successful, we could well see cities, condominiums of telescopes sprouting on the moon, as well as, of course, many other activities. The Galaxy Forum program that we're part of here operates in all 5 major continents and is striving to operate in Antarctica, the 7th continent. Many people in the space community regard the moon as the 8th continent. It's clearly Earth's moon. It belongs to Earth. And the benefits of exploring and developing and settling the moon are tremendous, I believe, and offer solutions to immediate problems on Earth. Different perspective, different direction, different inspiration. So that's what we hope to accomplish with this precursor, first toeholds on the moon, opening up a whole new frontier of science and exploration. Finally, what many of us who have been in this business for decades, motivated by the Apollo moon missions, was hugely successful American enterprises of the 60s and 70s when what were the 60s all about? I think, as a historian, and I'm trained as a historian, I think the 60s were about our becoming a multi-world species for a few glorious fleeting days. And it's a very interesting question, is how come nothing has returned to the moon, with the one exception that we mentioned, for 4 decades? It's a question and an answer I don't have. But in terms of energy and materials, opportunities for exploration, science, education, adventure, commerce, enrichment, Earth's closest neighbor has all of that, and is a gateway, I believe, and many of us do, to the rest of the solar system and beyond. And so the 4th mission that we're aiming for is a human mission to service the observatories, the robotic observatories that have been placed there earlier. And I'll have a few more comments about each of these missions as we go forward. The goals of the observatory, very briefly. We spent several years going around in circles asking hundreds of astronomers what to look at first, and we got several hundred answers. And a certain consensus developed that we wanted something big and bold and inspirational, and we settled on our own home galaxy, the central part of it. And so the first flight of our telescopes, the precursor and the ILO-1, will be on the central portion of the Milky Way galaxy. We'll tilt our instrument down across the lunar horizon to characterize the local surroundings, where all other development will occur, and then tilt the camera up to observe the Earth, long duration observation for environmental space weather pattern observations, and any number of other exciting objects on this new world for astronomy can be targeted. Extrasolar planets, searching for extraterrestrial life, analyzing the interstellar dust, molecules in the solar system, very long wavelength observation and searching for those big killer rocks, the NEOs, like the one that crashed over Russia last year, and many, many other objects. Our first mission, the ILO-1, we have very excited to introduce a new joint venture partner last week in Canada, Canadensis Corporation. That is their rendering on the top left there, with still a large dish and an optical telescope, perhaps several other secondary payloads, taking the first light of the Milky Way galaxy, transmitting the scientific data back to Earth, and with that transmission capacity, being able to conduct commercial communications as well. Our ILOA came out of our parent Space Age Publishing Company. We published a Space Calendar Weekly faithfully for 30-something years without fail, and we intend to broadcast it from the moon on a commercial basis. There's an artistic rendering of the first light of the Milky Way galaxy. Moon Express, which is developing our ILO-X precursor instrument, landing in mid-latitudes. There's another rendering of the Canadensis ILO-1 instrument. South pole of the moon has emerged after 20 years as the consensus destination for having the greatest assets and riches nearby, the greatest potential for future human lunar settlement and build-out. For our purposes, for our ILO purposes, the south pole of the moon and that 5,000-meter mountain has the advantages of extended power, perhaps 100% or at least 90% of the time. Much more favorable thermal conditions than the 500-degree Fahrenheit swing, day-night swing at the equator. Direct line of sight communications with Earth. The ice water in the crater, cold, deep crater traps that have been validated by big orbiting spacecraft. The riches of the Aitken Basin, the largest impact basin in the solar system, the treasure trove for geologists and mining. The southern hemisphere for astronomical observations, in particularly the Milky Way galaxy, and the south pole of the moon. Well, there's an analog that we can build and learn from the south pole of our planet, where in 1912 there was a competition to arrive there first. That was won by American explorer Shackleton, European explorer Shackleton. Nobody went back to the south pole of the moon for almost 50 years. And then in the 50s, when, just like the analogy with the moon, when people did start going back to the south pole of Earth, Antarctica, they went for scientific reasons. Now, 50 years later, there are 50,000 people a year that go to the south pole of Earth. When we have 50,000 people a year going to the moon, which certainly will happen in the 21st century, many other activities of civilization will rise. Here's a little close-up. Briefly, the history of our collaboration with the Chinese astronomers started in Hawaii 2 years ago with the visiting top Chinese scientists. The gentleman sitting on the left is was the executive director of our closest neighbor, the Canada-France Hawai'i telescope. This affords us, again, this instrument now is operating as we speak right now. There's a spacecraft operating on the moon. And it is imaging. The telescope works fine. It's small, it's limited, but it does afford us real-time operation on the moon. And it's interesting getting used to the day-night cycle, a little different than on Earth. It's 14 on, 14 off. The first MOU was supplemented last summer, 2013, and that's the the administrator of the Chinese National Space Association, looking at what you have before you, a galaxy map, and we traded that for an expensive model of their human spaceflight spacecraft there, the Shenzhou, so that exchange worked out pretty nicely. The principal investigator of the Chang'e 3 ultraviolet telescope, Professor Jinyan Wei, and I've met his entire team. We will be trying to image the first galaxy. It won't be the Milky Way, which is not in the field of view, but the first galaxy ever studied from the moon at the beginning of the next lunar day on November 3rd. Over here, you see the first images taken by the LUT from the moon, 23 stars in the constellation of, I guess, Draco, the dragon. And information is available about the technical details of the Lunar Ultraviolet Telescope. 15 centimeters, 1,024 pixels squared, operating in the day because it doesn't have power to operate at night. With a lifetime mission of 1 year, likely to be extended an extra year. The precursor mission, there's our instrument on the left. Excuse me. It sits waiting for launch atop of the Moon Express satellite, Moon Express Google Lunar X Prize spacecraft in Mountain View, California, at NASA Ames. That is a phase 2 demonstration instrument taking this image from the top of Mauna Kea, where we conducted live tests with our very distinguished board of directors, team of international scientists on 4 continents. And that's the image that we were able to get with the phase 2 instrument over there. This will allow students to conduct astronomy from their classrooms using the telescope on the moon. So they'll be operating in 2 worlds. We hope to bring that to high schools in particular. I visited my alma mater in Scarsdale when we started a Galaxy Forum program 4 years ago, and intend to continue it till we have Galaxy Forum Scarsdale High School 2111. And if the high schools in Hawaii don't get there first, students at Scarsdale High School may be the first ones to participate in astronomy from the moon, to go to school and be able to operate on 2 worlds. The human service mission in 2005-06, we conducted 2 technical studies with a company now no longer in existence because it's a very visionary founder and an energetic and charismatic individual. Jim Benson passed away. But we did a lot of precursor work for a human moon mission. I'm very, very happy to share the good news that our feature speaker of today, Dr. Alan Stern, also is a bold adventurer, a lunar entrepreneur as well. And 2 to 3 years ago, stepped into that vacancy of a private, independent human mission to the moon with a company called Golden Spike. And those of you familiar with Americana and American history will know that the Golden Spike was the spike that connected the eastern and western railroads that linked the American continent and opened up the continent's riches to many future generations. Golden Spike aims to open up a bridge, a railroad, a cislunar superhighway to the moon and the Earth. Our company, ILOA, is an early partner with Golden Spike, an investor, and we're very eager to see humans back on the moon. I asked Alan to speak on something even more exciting, although I don't know what's more exciting than being a multi-world species, but his talk will be on New Horizons. But if you have questions later for golden spike in the return of Americans and others to the moon, perhaps as soon as 2020. Please feel free to ask. Well, I'm going to move along fairly quickly now. Why is galaxy consciousness important? Why are we here? The name of this event is Galaxy 21st Century Education. I believe it's important for the reasons that I started in my preliminary remarks, that we're no longer confined to this solar system in our understanding of the universe, in our learning. Our neighborhood galaxy provides a new domain for exploration, for contacting other worlds and their civilizations more likely than not, perhaps sooner rather than later. So galaxy education is important for all classes. We intend to, we support the idea of a galaxy map in every class. Galaxy awareness, it dominates increasingly astrophysics in higher education. More and more professional astronomies are focused on galaxy studies. Galactic awareness, especially understanding the movement of the Earth and the Sun juxtaposed along the constellations of the ecliptic, provides lessons in archaeoastronomy, using the precession of the equinox to track human progress in history back thousands of years. Galaxy awareness helps macro planning organizations such as space agencies and such as NASA or the European Space Agency, India, China, Japan, Russia's space agencies, and others. And it seems like it's the natural thing, taking a look at the full span of the 21st century, to think in terms of what can we do with the solar system in the 21st century. We hope and we don't expect to stop at the moon or Mars. And finally, this idea of galaxy awareness, that the sun is not the center of the universe, just as Copernicus showed that the Earth is not the center of the universe, is a new, much enhanced and more powerful, more empowered understanding of our reality and the opportunities that it provides for everybody. And just as galacticity, just as relativity may have been one of the leading ideas of the 20th century, so galacticity may be one of the leading ideas of the 21st century. When we went to the moon 40, 50 years ago, humans stood on the moon and looked back at our home on Earth with profound consequences, as you all know. Or maybe many of you weren't born then, but that is indeed where environmental, ecological consciousness emerged from. When humans go back to the moon in the 21st century, not only will they stand and look back at home, but we'll look out at our future, out towards the galaxy for inspiration and direction. Milky Way galaxy, won't go into details. You have your maps, 2 major arms, 4 spiral arms. The center, the galactic center, is 26,000 light years from us. Astronomy from the moon or from Earth actually rendered these images of the same area of the Milky Way, different wavelengths, produce different scientific data and information. You can see all the different wavelengths used to get the different scientific data of the Milky Way. Our galaxy forum has been held in these locations. It's the case all around the world: California, Hawaii, Kansas. I don't know if anybody knows what the state motto of Kansas is. It's ad astra per aspera, to the stars through difficulties. Midway, USA. In Canada, China, Europe, Japan, Africa, South America, Southeast Asia. And as I say, we're aiming for the 7th continent, Antarctica, and eventually for the 8th continent. Those are some of the locations. The star just south of our home base in Hawaii, which we also refer to as Galaxy Central. Shows the debarkation, the launch site for the Sea Launch Complex, where rockets launch satellites in the center of the Pacific Hemisphere. We've held events like this with a variety of speakers and a variety of topics. In South Africa, Canada, China, South America, Brazil. A few exemplary teachers of galacticity, of galaxy education. Krista McAuliffe's backup, Barbara Morgan, the first teacher in space who persisted 22 years to get her position, starts her third grade classes by showing a picture of the Milky Way galaxy, claiming it's the most important thing she can teach her students, her third graders. And she ends by showing a picture of the Hubble Wide Field. Fascinating information showing being able to observe stars circling the supermassive black hole at the center and subsequently disappearing over the event horizon. As I mentioned, Galaxy 21st Century focuses on the solar system. Just imagine the opportunities and excitement of the civilizations that will arrive around Jupiter and Saturn and their dozens and dozens of moons. Galaxy education resources are plentiful. Those are just some of the organizations you can find by searching online easy enough. We work with International Space University, Planetary Society, SETI Institute, Space Generation, Challenger Center, and many others. We are a multi-world organization, a two-world organization based in the center of the Pacific Hemisphere on Hawaii's Big Island, an hour's drive to the top of Mauna Kea, the center of world astronomy in the northern hemisphere. Hawaii is an excellent place to access the space in the solar system. We've begun with a grant that we've received to do architectural studies on our headquarters. And we expect the headquarters to break ground in 2016, to open in 2017 in conjunction with operations on the moon. Architectural studies have been completed. And we'll use the headquarters as a center for receiving data from the moon, processing it, educating students and teachers, and receiving international delegations. There's a picture of where I do a lot of work and planning. An hour's drive from my office. I've been up there hundreds of times. We go there during lunch break. 12 observatories supported by 12 or 13 countries already in an international space city. The image up on the right shows the TMT 30-meter telescope, which amidst some controversy has begun construction to keep Hawaii at the forefront of astronomy in the 21st century. I welcome you all in the spirit of aloha to our office, and please, I hope to hear from you when you do make it over to the 50th state, 60 time zones, 6 time zones from us now. So thank you for your attention to that. I'd be happy to answer questions. Perhaps later, if there's any one question now. I do want to thank you for your attention. Move along to our featured speaker. So. Okay, well, here I am again. I'm very, very happy to, I can't tell you how lucky I think we are to have Dr. Alan Stern here with us today. Alan gave 2 very, very spirited presentations at Scarsdale High School as part of our Galaxy Forum Scarsdale High School program, the 4th such program at the high school yesterday. As I mentioned, he's a man of many, many, many enterprises all over the solar system. And we're going to hear what I believe Alan regards as his one of his most exciting ventures, the New Horizons spacecraft, which probably will be the leading science story, as I mentioned before, in the world in 2015. And I hope it's one of the leading stories, period, in the world in 2015. You know, right up there with all the other challenging stories. I also wanted to single out Alan's courageous initiative to try and get us back to the moon ASAP.